Good day to all of you engineers. As promised, this is now Coaching ESAT 2. We will be completing our top coaching series for ESAT. And this is now the second part. Siyempre, meron pa tayong third part. So, pakakaabangan nyo rin yun para makompleto na natin ito. And lagi ko ang sinasabi na sana makatulong ito pagdating sa board exams ninyo. Yun naman talaga ang purpose natin kung bakit tayo nagre-review to pass the board exams. And if you want to become a top-notcher, ESAT is very essential together with electronics engineering because each one of them is 30% in rating pagdating sa overall ng board exams. No? Math and GS is 20% apiece to complete the 100%. Okay? Kaya galingan natin kahit na ano pang subject yan. Pero sa ngayon, ESAT muna tayo. Again, I'm Engineer Melvin Arceo. If you're ready, I'm ready. Let's get it on. Question number 1. It is the only digitally encoded modulation technique. What do we call that? Apat lang naman yan. No? We have the PAM, pulse amplitude modulation. We have the pulse width modulation and the pulse position modulation. Together with, of course, the pulse code modulation. Ang pulse code modulation has constant width, constant amplitude, and constant position. Yung sampled signal, which is quantized, kino-convert into binary. That is why PCM is called the only digitally encoded modulation technique. So number 1, letter A. Question number 2. Type of multiplexing that simply constitutes propagating signals from different sources on different cables that are contained with the same trench. Now when we say trench is considered as a transmission medium. So, ibig sabihin, if you have different sources and you put it on different cables, those different cables are enclosed to a one particular medium. So, para lang siyang pinagsama-sama na media into one medium. Okay? Anong tawag natin sa multiplexing na yun? That multiplexing is called space division multiplexing. For number 2, letter B. Okay? Question number 3. A digital line encoding, if the binary pulse is maintained the entire bit time, this is called, na-lecture ko na sa inyo ito, di ba? Kapag ka yung bit duration is 100% a duty cycle, meaning it will occupy the entire duration for bit 1, or if that is bit 0, for the entire duration for bit 0, we call this non-return to 0. If anything that is less than 100% duty cycle for 1 and 0, basta less than 100%, ang tawag mo doon, return to 0. Pero pagka entire bit time, meaning 100% duty cycle, that is non-return to 0. Okay? Pakitandaan po natin yan. For number 3, letter B. Next number 4. Attenuation of the surface wave due to absorption depends on the conductivity of Earth's atmosphere, Earth's surface, frequency of the electromagnetic wave, or both Earth's surface and frequency of the electromagnetic wave. Take note, attenuation of the surface wave due to absorption depends on the conductivity of, tatandaan po natin yan, letter D, both Earth's surface and frequency of electromagnetic waves. Okay? Question number 5. The E layer of the ionosphere reflects blank during the daytime. During the daytime, may E layer pa. During the nighttime, nawawala siya together with the D layer. So pagka daytime, ano raw yung nire-reflect niya? Ang nire-reflect niya is, actually it aids the MF or the medium frequency. But, and it will reflect some of the HF or the high frequency. That's for number 5, letter B. Question number 6. It is the minimum distance from the transmit antenna that a sky wave at a given frequency will be returned to Earth. Ano raw yung minimum distance na kapag nag-beam tayo sa ionosphere? For example, this is your transmitter, this is your ionosphere. kapag nag-beam tayo, yung minimum distance na babalik yung signal natin. We call this distance as the skip distance. Okay, so obviously, ang sagot natin dyan is letter A, skip distance. Okay? Question number 7. Each pole of the half-wave antenna looks as if it were an open quarter wavelength section transmission line. Thus, there's a voltage maximum and current minimum at the blank and a voltage minimum and current maximum at the blank. So, ang tinatanong dito, puro blank. Correct? Okay. Ano ba yung tinutukoy niya? Yung half-wave daw kasi, para daw kasing ano to eh, para daw siyang quarter wavelength. And sure enough, dalawang quarter wavelength talaga yan. Tama? So ito ay half wave, for example. Yan, half wave yan. Natural, half wave is composed of two quarter wavelengths antenna. Okay? So para siyang binuka na quarter wavelength na transmission line. And of course, dalawang quarter wavelength, half wavelength yan. So ang tinutukoy, ang tinatanong niya ay yung dulo at saka itong gitna. Ano raw yung voltage natin doon sa dulo? Ano raw yung voltage natin sa gitna? The same as with the current and current at the ends and voltage current at the center. Okay? So madali lang naman ito, no? For example, this is voltage. The voltage at the ends will look like this. Yan. Samantalang yung current at the ends ay ganito naman. So, anong ibig sabihin? Yung current natin sa end ay ano? Minimum. Pero yung current natin sa center ay ano? Maximum naman siya. Yung voltage naman at the end on both ends will be maximum and ang voltage naman natin sa center will be minimum. So, voltage maximum and current minimum. Voltage maximum, current minimum at the end. Okay, so dalawa na lang yan, A at saka D. And then voltage minimum and current maximum where? At the middle. Okay, so the answer obviously is letter D. At the end, maximum voltage, minimum current, and at the middle, voltage is minimum, current is maximum. Okay? Okay. Next number 8. Question number 8. It is formed when two or more antenna elements are combined to form a single antenna. Anong tawag natin dyan? Group, array, entity, herd. Ano yung herd? Parang hayop ito, grupo ng hayop. Okay? Pero hindi herd yan. No? Ang tamang sagot ay letter B, array. Question number 9. What polarization is used by helical antenna? It's not horizontal, it's not vertical. It is letter B, circular, for number 9. Letter B. Question number 10. For a 2-meter diameter parabolic reflector with 10 watts of power radiated by the feed mechanism operating at 6 GHz with transmit antenna efficiency of 55% and an aperture efficiency of 55%, determine the beam width and transmit power gain. Okay? So, paano ba ang pag-calculate ng beam width and transmit power gain? We use this equation. For the gain, that is 6 times d over lambda squared. For the beam width, that is 70 lambda over d. So, both of them can be calculated and the correct answer is, of course, in this choices. No? So, hanapin muna natin yung gain. Pero bago natin makuha yung gain, we must first solve for the wavelength or the lambda. That is C over F. And of course, C is constant. That is 300 times 10 to the 6 meters per second. Okay. Divided by the frequency, which is given din yung frequency, that's 6 gigahertz. So 6 times 10 to the 9 hertz. Okay, we can easily calculate for the wavelength and that is equal to 0.05 meters. Of course, na-calculate ko na kanina yan. Na-verify natin. Pakitandaan nyo po yung wavelength kasi gagamitin natin yan doon sa gain natin. So, yung gain is equal to 6 times, ano raw yung diameter? The diameter is 2 meters. Tama? While the wavelength is 0.05 meters or meter. Okay? Squared, of course. And ano yung magiging gain natin in dB? Kasi naka-dB yung nasa choices natin. That's in dB. Okay? So whatever you get for whatever value you get in calculating for the gain, pagka kinonvert natin yan in dB, will be substituted to this equation. So that is 10 log of G, where G is any uh, value you have get in this calculation, you will get the gain in dB. And in that case, that will be 39.82. Tama? Dalawa yung given na 39.82. So, makaka-conclude na lang yan pag na-compute natin yung beam width. So, beam width is equal to 70, given naman na din yung, yung diameter, at yung wavelength natin ay nakuha na natin kanina. So, wavelength is 0.05 meters and 2 meters. Okay, yung diameter ng parabola. Therefore, the beam width will be equal to what? Ayan, kung ano man makuha nyo dyan, 17.5 degrees or 1.75 degrees. That is letter C, 1.75 degrees. Ang tanong, sir, hindi na ba kasama yung aperture error, aperture efficiency, na 55%? Actually, hindi na, no? Kasi ang original na, ito kasi ay derived lang ito na this is only a derived equation. The equation really for the gain of the antenna is efficiency times lambda pi d over lambda squared. Okay? Where this is now your efficiency. And if that is 55%, pwede natin ma-derive yung gain as this. Pero kung less than 50% or more than 70%, pwede mo nang computein ito as exactly as possible. No? Pero kung gagamitin mo rin yan dito, okay lang din. Wala namang problema. And may kita natin na yung value is almost the same as with 39.82 dB. So the correct answer for number 10 is letter C. Okay?